Hello guys, today we are going to discuss about types of data in cluster analysis. So we will discuss this topic today, and this is one of the important question in the unit 4 again. So if you are having any exams means or any specific topics you need means please just give the topics that which you need in the comment section so that I can upload that type of videos. And those who are watching for the first time, please like, share and subscribe my channel. And let's go into the topic now. See how the first what is meant by cluster analysis. Clustering means it is nothing but all the similar or the group, all the similar items, we will make it into separate groups. That is called as the clustering. So here we are having different types of data will be there in the data sets. Usually it can be interval scaled variables, or it can be binary variables, or categorical variables, nominal variables, ordinal variables and all. But still we should be able to figure out how the clusters will be formed in a proper manner. That is today's topic, how for the different types of data, how the cluster analysis can be done here. But for the numerical data, we can use some few techniques like calculating the Euclidean distance, or Manhattan distance, or Minkowski distance and all. But if any categorical data is there, then how we can do the cluster analysis and all. See, first step is the data set that can be clustered contains n objects will be there, which may represent all the 10 objects can be represented like persons, names, houses, documents, countries, and so on. Here we can represent our given object by variable structure in the form of a data matrix. How the data matrix can be represented means here it will consist of n objects will be there and p variables will be there, where we can represent our matrix in the form of n by p matrix here. What is that n means? N objects means it will show the person's names, whereas p variables means it will show the measurements or the attributes names. So attributes names means the properties of a given variable can be represented as the attributes names, such as the height, gender, what is the weight, everything we can represent in the form of a n by p matrix. That is the n objects and the p variables. Next, how to calculate the dissimilarity matrix for object by object structure. So this will store the collection of proximities. Proximities means nothing but the distance between the two variables or the two objects that are available for all the pairs of n objects. So how we can represent these objects means in the form of n by n table. In the form of n by n table we can represent here. So this is my given matrix here, and all the diagonal elements can be shown like 0 here, whereas the row and column both will be same. So wherever we are having the row and column both will be same, that we have shown it like a 0 in the dissimilarity matrix. But a d of 2 comma 1, it is nothing but in the second row first column, this is nothing but the distance between those two objects. So the distance of 2 comma 1, distance of 3 comma 1, and so on till distance of n comma 1. So like that we have written for the other things also. So this is called as the dissimilarity matrix. So where d of I comma j, it is nothing but the measured difference or dissimilarity between the objects I and j. So in general, d of I comma j is a non-negative number. D of I comma j is a non-negative number, and if it is close to 0 when the objects I and j are highly similar or near to each other. Suppose if you take this one, d of 1 comma 1, it is 0. So that we can say that I and j are highly similar and nearer to each other, and becomes larger the more they differ. So if the distance is more means that means the difference is more here. So here distance of I comma j, we can treat it like a distance of I comma j or distance of j comma I. Both are same, and the distance between I comma I will be always 0 here. So this is the way how to construct the first dissimilarity matrix. So first matrix is we have to construct the data matrix with n by p matrix, and second one is the dissimilarity matrix. This is nothing but the how to calculate the dissimilarity matrix for the given objects n and the given variables. And the rows and columns of the given data matrix represent the different entities, while those of the dissimilarity matrix represent the same entities. And the data matrix is often called as the two-mode matrix, whereas the dissimilarity matrix, we will call it like one mode matrix only. So many clustering algorithms usually they will operate on the dissimilarity matrix only. So if the data are presented in the form of a data matrix means it can be first transformed into the dissimilarity matrix. Before applying the clustering algorithms, we will frame the dissimilarity matrix. So first we will see how the dissimilarity matrices will be calculated for the interval scaled variables. So first, what are interval scaled variables? We know that for a given data we can represent in the form of a continuous measurement, or in the form of some few intervals we will represent like 10 to 20 or 20 to 30 or 30 to 40, like that. In the form of few intervals I can represent my given data based upon the given data sets. So that's why they gave like a interval scaled variables are continuous measurements of a roughly linear scale. So the typical examples include weight and height. Typical examples include weight and height, latitude and longitude coordinates, and the weather temperature. Latitude and longitude coordinates and the weather temperature. So the measurement unit which will affect the clustering analysis here. So for example, if you want to change the measurement units from meters to inches for height, or from kilograms to pounds for weight, that means if there is any variation in the units means definitely it may lead to different clustering structure. So if we are having the same units for all the different data types, we can get the clustering in a proper manner. That means we will get the good clustering results here. So that's why see that the measurement unit should be correct while doing the clustering analysis. So how the data variable can be standardized. How the data variable can be standardized means standardization, it is nothing but a normalization technique in the data. So what is meant by normalization here? Usually normalization means if any large decimal values of your data will be there, we will try to reduce that particular data in the smaller figures. That is called as the normalization. So we are having the different normalization techniques also. We are having like a min max normalization, z score normalization, and normalization by decimal scaling. So different normalization techniques are there based upon the given variables. We will try to see the normalization techniques here. So here we will see how they are going to calculate the mean absolute deviation SF. So SF is equal to 1 by n into x1f minus mf. Mf is nothing but the mean value of the f, and where x1f to xnf are the n measurements of f, and mf is the mean value. Mf is nothing but the mean value of s, that is mf is equal to, it is nothing but the total number of observations by the sum of observations by the total number of observations, which will gives you the mean value here. Next one is the standardized measurement. So this type of measurement we will call it like the z-score normalization. So for the z-score normalization we need the mean value, and as well as we need the standard deviation. Then only we can calculate the z-score normalization. So z-score normalization can be represented by ZIF. ZIF is equal to XIF minus MF by SF. So SF stands for the standard deviation and MF stands for the mean value. Next, after standardization, first step is we have to go for the standardization, and or without standardization in certain applications, the dissimilarity or the similarity between the objects can be described by the interval scaled variables. How? With the help of the distance between the pair of objects. With the help of the distance between the pair of objects. Now, the question is how to calculate the distance between the two variables. So we know that we can calculate the distance between the two variables with the help of Euclidean distance. So what is that Euclidean distance here? D of I comma j is equal to square root of xin minus xj1 whole square plus xi2 minus xj2 whole square plus till and so on xin minus xjn whole square. So this is the way how to calculate the Euclidean distance. If you want to find out the distance between the two variables, that is the or the two objects I comma z. Or another well-known metric is there, that is called as the Manhattan distance. So in the Manhattan distance, we can call it like Manhattan distance or city block distance. So how we can represent that one means, we'll see based upon the given variables. See, based upon the distance here, So they have figured something here, that is d of I comma j is greater than or equal to 0 means distance is a non-negative number. It is not a negative number. And d of I comma I is equal to 0 means the distance of an object to itself is 0. And d of I comma j is equal to d of j comma I, where distance is a symmetric function. And d of I comma j is less than or equal to d of I comma h plus d of h comma j. That means if you want to go directly from I to j, that is okay. But if any intermediate values are there means, then we have to go with the d of I comma h plus d of h comma I. So if you are going to take this particular route means, but still your value should be less than this total distance. So those are the rules that which we are having for the distance. And see here Euclidean distance and the Manhattan distance. I have taken the one example like let x1 is equal to x1. I am having the two values 1 comma 2 and x2 is equal to 3 comma 5, where it will represent the two objects. So how to calculate the distance between the two? So what is the equation? We know that x2 minus x1 whole square plus y2 minus y1 whole square. That is our formula here for calculating the Euclidean distance. Now, we have to apply the same formula for calculating between the x1 and the x2 distance here. So, how much we will get? 3 minus 1 whole square, square root of 3 minus 1 whole square plus 5 minus 2 whole square, which will give some value, that is the 3.61. So, the Manhattan distance between the two is, what is the Manhattan distance between the two? That is the 2 plus 3 is equal to 5 we will get. Why? Because in the Manhattan distance we don't have any squaring of the values here. So directly we will take the values, the subtraction and the summation of the values. And what is the Minkowski distance? This is a generalization of both the Euclidean distance and the Manhattan distance. So d of I comma j is equal to xi1, that is mod of xi1 minus xj1 power p plus xi2 minus xj2 power p plus and so on, like power 1 by p, where p is a positive number, whereas the distance is called as the LP norm, and it will represent the Manhattan distance when p is equal to 1. So here if any weights are there, then in such cases also we can calculate the Euclidean distance. So that is if any weights are there, weights can be represented by W1, W2, W3, like that we can represent the weights. So this is the equation for calculating if for each variables if they have assigned the weights means, this is the given equation here. And suppose that is the case of the interval scaled variables. Suppose if I am having the binary variables, we know binary variables means it will represent only two values, that is 0 and 1, or true or false, yes or no. So like that only two variables can be represented here. Then how to compute the dissimilarity for the binary variables? So this is the equation which they have given it here, that is for the symmetric or the asymmetric variables. So here this is my first value, that is 1 comma 2 x1 and x2 is the 3 comma 5. Then how to calculate? We know how to calculate the Euclidean distance, and this is my Manhattan distance. How much I got? 3.61. And for the Manhattan distance we got the value like 5. See here the same explanation here they have given. For a binary variables only two states will be there, that is 0 comma 1. 0 represents the variable is absent, and whereas 1 means the value is present. Suppose if you take the example of a smoker describing a patient, how we can describe here? 1 indicates that a patient will smoke and 0 indicates that the patient doesn't smoke. So only with the help of two variables I can represent my variable smoker here. And how to compute the dissimilarity between the two binary variables here. So to compute the dissimilarity matrix for the two binary variables, see here I am going to maintain the contingency table for the binary variables. What is that contingency table here? Means the contingency table will consist of these object I will be there and as well as object j will be there, where here on the first row I am having the 1 and 0 sum will be there, and here 1 0 sum will be there, but here the matrix can be represented like us with the help of some few letters, that is Q, R, S, T, and this is the summation of the first row or the first column, that is the Q plus S, and here we will get the summation of R plus T, here we will get the summation of Q plus R, here S plus T, and here finally the entire sum will be represented by the P here. Then the dissimilarity that is based upon the symmetric binary variables is called as the symmetric binary dissimilarity. Its dissimilarity measure defined in the below equation. How we can find out the dissimilarity with to access the dissimilarity between the objects I and j. So that is d of I comma j is equal to, this is my equation, that is r plus s by q plus r plus s plus t. This is my dissimilarity between the objects I and j. This contingency table is very important for the binary variables. See, a binary variable is asymmetric if, when it is asymmetric here, if the outcomes of the states are not equally important. How I can say that my output is not equally important here? Suppose let's take the example of positive and the negative outcomes of a disease test. Suppose if we are having the COVID test, let's take the example of the COVID only. So we are having the positive cases will be there and negative cases will be there. So to which one we will give the more importance? We will give the more importance for the positive cases and less importance to the negative cases. So such a type of things can be considered as the binary variables, as the asymmetric binary variables. So we shall quote the important outcomes which is represented by the one value, and this is one more example like a HIV positive test and HIV negative test. So such type of variables can be represented as the asymmetric binary variables. And we are having the two more variables are there, that is the asymmetric binary variables. The agreement of two ones is considered as more significant than the two zeros here. So here how the dissimilarity can be constructed means d of I comma j is equal to r plus s by q plus r plus s plus t is not there. We have removed the t value. Why? Because see here we are not taking any negative values. We are taking only the positive values. So that's why if you observe this particular thing, this t will gives you the representation of this entire total summation here, p plus q plus r plus t here. So that's why we have removed that one in the asymmetric binary asymmetric values here. Where if any negative matches are there, we are going to remove that negative matches. Why? Because in the binary asymmetric, we will not give that much importance to the negative value. So that's why we have removed the entire negative value matches here. And for the asymmetric binary dissimilarity, the objects for the j and we can calculate the similarity of I comma j like a similarity of I comma j is equal to q by q plus r plus s is equal to 1 minus d of I comma j. Whereas this similarity quotient, it is called as a one specific name is there, that is called as the Jaccard quotient. We can call it like the Jaccard quotient here. And see here how the dissimilarity between the binary variables can be represented means. See, if you observe this one, that is d of Jack comma Mary. They will give the relational table with the help of some positive and the negative values, and with the help of some binary values also they will give you. So what we have to do it here, wherever we are having the s values or positive values are there, we will replace it with 1, with the variable 1, and wherever we are having negative values are there and no values are there means we will replace it with the 0 values. Then if you want to know how the dissimilarity is there between the binary variables, that means between the Jack and Mary and between the Jack and Jim, or between the Mary and the Jim, means how we have to calculate means based upon the equation, that is r plus s by q plus r plus s. So whenever you are going to replace the values with the 1010 means you are going to get the Jack comma Mary is equal to r plus s. Where is my r value here? Here I have to consider where is my r value here? This is my r value. R is going to represent 1 comma 0. Wherever 1 comma 0 is there in your table, wherever we have to replace it, this particular table with the ones and zeros. So I have to find out wherever 0 and 1s are there, how many times that 1 and 0 is repeated. So that can be taken as the value 0. And in the same way for the s and q r plus s by q plus r plus s, so that we will get this value, that is 0.33. And Jack and Jim also we will see the same manner. Jack and Jim, how many times your r value is repeated and for which values we are going to take. Suppose if we are having the values of fever, how I can replace my values here, means see if I'm having yes, 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 that means all ones will be there. And here no means 0. I have to replace it with 0, 0, and then 1. And here a positive means 1, 1, 0. And here negative means 0, 0, 0. And here negative means 0, positive means 1, 0, and 0, 0, 0. All three zeros we will get hit here. So if you want to write what is my equation here, r plus s by q plus r plus yes, q plus r plus yes. So we have to remember what is that r value. So with the help of the contingency table, what is that r value? Where is my r value here? R is going to represent a 1 0. So let's take in the table where is 1 0. Between the Jack and Mary, I have to check 1 0. Wherever it is repeated, here only 1 1 is there. 0 0, 1 1, 0 0, 0 1, and 1 0. So that means no 1 0 values are there. So that's why I'm going to replace it with 0. My R value is 0. No values are there with 1 0. Next, yes. So what is my S value here? Let us check where it is my S. My S will gives you the 0 and 1. I will check with these variables where 0 and 1 is repeated. Here 1 1 is there, 0 1. So here we got 1 times 0 1. So I'm going to replace my S value with 1. Next, what is my Q value here? Let us check my table. Where is Q value means 1 1. Q value will represent 1 1. See, where is my 1 1 value here? So here 1 1 value is there, here 1 1. 2 times it is repeated. So I'm going to replace my Q value like 2. Then what about R value here? R value we will get 0 only. Why? Because already in the numerator we are having 0. And again S value we will get 1. So if you compute this one, again you will get 0.33. So this is the way how we can figure out for the binary variables. So whenever they are going to give any such type of this relational table, we have to replace it with one, all the positive p values and the positive values we have to replace it with 1. All the negative values and the we have to replace it with 0, so that we can compute with the help of this contingency equation. I can compute like this, so that I can figure it out whether any dissimilarity is there between the variables. Next one is for the cardinal and ordinal and the ratio scaled variables. Then how to compute the dissimilarity between the objects described by the categorical, ordinal, and the ratio scaled variables. Categorical variables means we know that it will not take only two forms or the two states like binary variables. So we are having many number of values will be there for the categorical variables. So if you take the example of the map color here, it is a categorical variable that may have say 5 states will be there for a map color like red, green, blue, pink, yellow, like the different kinds of map colors will be there. So those that is called as the categorical variables. Suppose if your data consisting of such a type of categorical variables means how to compute the dissimilarity between the objects. So this is the equation for computing the dissimilarity of the objects, that is d of I comma j is equal to p minus m by p. So this is the equation that which we are having for computing the categorical variables. And see how the dissimilarity can be categorized, can be calculated for the categorical variables. Suppose if we are having the sample data like this, like object identifiers I am having, and test one categorical data I am having like categorical data A, B, C, A, and what is my test values here? I am having the excellent, fair, good, and excellent values are there. And test 3 values are there. That means these are for the categorical, this is for the ordinal, and this is for the ratio scaled variables. Suppose if we have the categorical variables for the test 1, we will set p is equal to 1. We will set p is equal to 1 in the equation 7 point. And how to calculate the dissimilarity of I comma j, which will evaluates to the 0. If it matches I comma j, if it is going to match means, mm, see, if the d of I comma j is will be evaluated to 0 if both are same. That means if I comma j will matches means we will keep the values as 0. So actually based upon these things only we are going to represent for the categorical variables. So all the diagonal elements are 0. What are the diagonal elements here? D of 1 comma 1, this is D of 2 comma 2, D of 3 comma 3 and D of 4 comma 4. So here again we will get to D of 2 comma 1, 3 comma 1, 4 comma 1. 3 comma 2, 4 comma 2 and 4 comma 3. And how to see the values here? If you see here d of 2 comma 1, so anyway all these diagonal elements we will get the 0 only. Let's check for the d of 2 comma 1. What is that 2 comma 1? So this is my 2 value and this is my 1 value. So can you say that code A and code B both are similar here? Definitely no. So if both are different, I will keep the value as 1. In the same way, I have to check for the d of 3 comma 1. Where is my 3 comma 1 value here? 3 and 1. So again these two also will be deferred. So I will keep the value like 1. Then what about 4 comma 1? Let's check 4 comma 1. So code A here and code A here. Both are matching. So what I will do? I will keep the value as 0. So let us check for the D of 3 comma 2. What is the D of 3 comma 2? 3 comma 2 means here code C is there and code B is there. Both are different. So that's why I will get the value like 1. And for the D of 4 comma 2 again, I will get the value like 1 only. Why? Because both are different. B is there and here A is there. So like that we have to check it for the categorical variables and we have to figure out the dissimilarity matrices. Next, we will go for the ordinal variables. So let's see the ordinal variables here. So for the ordinal variables means these ordinal variables simply they will resemble like the categorical variables only. But the thing is here m states of the ordinal variables are ordered in some meaningful sequences here. So for example, we will take the professional ranks are often enumerated in the sequential order. Suppose if any professional ranks are there, how we will calculate the professional order? If you take the faculty list only, we will give the ranking like assistant professor, associate professor, and the professors. So we will give some variables like 0, 1, 2, 3 like that. So those are called as the ordinal variables. In some specific order, we will give that things. And a continuous ordinal variable looks like a set of continuous data of the unknown scale here. Then how to calculate the dissimilarity matrices for the ordinal variables. So if we are having any sample data, except that this time sample data means we are having the object identifiers will be there and continuous ordinal variables will be there. So for these variables, we are having the values like fair, good and excellent. So for the fair, good and excellent, I am having only 3 values are there. So for these 3 values, I will take my MF value is equal to 3. And for the step 1, if we replace each value for the test 2 by its rank. So I can replace my test 2 values by the ranking value. The 4 objects are assigned to the ranks here. So what type of ranks I can assign it here? 1, 2 and 3. For the fair, I am going to give it like 1, 2. For the good and for the 3, it is excellent. So which table I have to take it means this table. So for this table, I will take the whatever the values I will get here. For the fair, I am going to take the value like 1. Good is 2. And for the excellent, I am going to take the values like 3. Right? So I am going to replace the values like this with the for the ordinal variables here. So if you are going to assign the ranks, we will get the ranks like this 3, 1, 2, 3 like that we will get. And in the step 2, that is the first step here, assigning the ranks to each and every variables is the first step. And in the second step, we have to normalize the ranking by mapping the rank 1 to 0.0. We have to do the normalization for the ranking here. And from the rank 2 to 0.5 and from the rank 3 to 1.0. And in the step 3, we have to use the Euclidean distance, which will result in the dissimilarity matrix here. So if you are calculating the Euclidean distance, then we will get the Euclidean distance like this. So that's all for today, guys. I think hope you understand this video. Don't forget to like, share, and subscribe, guys. Thank you for watching.